Welcome to the Reset Control Unit, RSTCU chapter of the HT32 MCU basic tutorial. This chapter will introduce the RSTCU function of HT32 MCUs from four aspects: functional introduction, block diagram and functional description, registers, and an application example. Part 1, Reset Functional Introduction. In this part, we will introduce what reset is and why it is required. What is reset? The whole MCU usage process can be roughly divided into two stages, namely the power supply stage and the program execution stage. During the power supply stage, the system will generate a reset signal after waiting for the power supply to stabilize. The reset signal will restore all registers and internal states of the MCU to the initial state. During the program execution stage, when the system has detected a reset signal, it will reset all the registers and internal states of the MCU to the initial state. So back to our original question, what is reset? Reset refers to restoring all registers and internal states of the MCU to the initial state. Why do we need to reset? We will analyze the two phases of MCU usage. During the power supply stage, all the registers and internal states of the MCU are uncertain after powered on, so reset function is required to reset the registers and internal states to the default values to provide a clear and stable execution environment for the MCU's subsequent operations. During the program execution stage, whether it is a strong external interference, low supply voltage, or program execution error, it may cause the MCU execution process to be interrupted and enter the software deadlock or downtime state. In this state, the MCU is no longer able to execute the program and implement the function normally. In this case, we can only reset the MCU to restore the system to the initial state and re-execute. Back to the original question, so why do we need to reset? In order to restore the system from an uncertain state to the initial state. Part 2, RSTCU block diagram and functional description. In this part we will introduce the reset function and reset types of HT32 MCUs. Next, we will briefly introduce the block diagram of the reset control unit. This part on the left shows the reset types provided by the MCU. The part on the right shows the MCU core. The middle part shows there are two types of signals used to externally reset the core, namely system reset and power reset. In the reset types provided by the MCU on the left, it can be subdivided into power on reset or power down reset, system reset, AHB and APB unit reset. We will introduce these three types of reset in more detail later. First, the power on reset is a process from supplying power to the MCU until the MCU enters the initial state. During this process, the various power and reset signals within the MCU must follow a specified sequence order for the MCU to properly enter the initial state. First of all, VDD starts to supply power. After waiting for 25 microseconds, when the MCU internal LDO voltage regulator is ready to provide a V-core power, V-core will start to supply power. After VDD supplying power for 100 microseconds, the MCU will generate a power reset signal, PO or reset N. This signal will reset the system debug components. After generating the power reset signal for 150 microseconds, the MCU will generate a system reset signal, SYS reset N. The signal together with the power reset signal will reset the system components, core, interrupts and other modules. Now the MCU will officially enter the initial state. The power on reset corresponds to the power down reset. When the MCU has detected that the supply voltage VDD is lower than the preset threshold VPDR, the MCU will perform a power down reset. Unlike power on reset, the power down reset can be selected by configuring the relevant registers to generate a power down reset interrupt when the voltage is larger than VPDR. Power on reset is mainly to allow the MCU to have an initial execution environment before executing the official program. Power down reset refers to the generation of a power down reset interrupt when the VDD voltage is lower than the set threshold, so that the system can prepare for the upcoming power down reset, such as reminding the system to store some important data. The system reset are used to restore the whole MCU system to its initial state. In the HT32 MCUs, the following methods can be provided for restoring the MCU system to the initial state. Power on reset. Watchdog timer reset. RST pin reset. Software reset. These different types of reset have their own different functions. The power on reset is used to prepare an initial program execution environment for the MCU. The watchdog timer reset is used to prevent the software from deadlocking or failing to operate normally after a crash. The RST pin reset allows the user to manually reset the pin according to their own needs. Software reset is used to enable the MCU to perform reset operations by calling software reset during normal program execution. Unlike the whole system reset, the HT32 MCUs also provide the AHB and APB unit resets to reset each peripheral. The AHB and APB unit reset can restore the specified peripheral registers connected to the AHB and APB buses to the system default register values. Therefore, what are the peripherals connected to the AHB and APB buses? The peripherals connected to the AHB bus are USB, GPIO, CRC, EBI, and PDMA. The peripherals connected to the APB bus are SCI, I2S, EXTI, AFIO, UART, USART, SPI, I2C, ADC, CMP, BFTM, SCTM, GPTM, WDT, MCTM. Part 3, RSTCU Registers. In this part, we will learn about the functions and roles of the HT32 MCU Reset Control Unit registers. We will briefly introduce the related registers of the Reset Control Unit. The Global Reset Status Register is used to record the various conditions of the MCU reset state. The AHB Peripheral Reset Register is used to control the software reset of AHB peripherals. The APB Peripheral Reset Register 0 and APB Peripheral Reset Register 1 are used to control the software reset of APB peripherals. The Global Reset Status Register GRSR is used to store the source of the last reset. After the MCU resets, we can read the register value to determine what the reset source was for the MCU last reset. As shown in the GRSR register, the MCU has four main reset sources: power on reset, watchdog timer reset, external pin reset, and NVIC reset. Power on reset: when a MCU reset occurs during the MCU powered on, the flag will be set. Watchdog reset: when the MCU resets due to the watchdog timer overflow, the flag will be set. External pin reset: when the user resets the MCU by using the external RST pin, the flag will be set. NVIC reset: when the program resets the MCU by calling the software reset, the flag will be set. The values of the flags in the GRSR register are not clear due to a read or reset operation. Users should call the function provided in the standard peripheral firmware library to clear it. The standard peripheral firmware library provides three functions to read and clear the reset source flags of the MCU. The function is used to read whether the specified reset source flag is set or not. The function is used to clear the specified reset source flag. The function is used to clear all reset source flags. The AHB Peripheral Reset Register, AHB-PRSTR, is used to reset the peripherals connected to the AHB bus. The specified peripheral can be reset by writing 1 to the specified bit in the AHB-PRSTR register. The APB-PRSTR0 and APB-PRSTR1 registers are APB Peripheral Reset Registers. These registers are used to reset the peripherals connected to the APB bus. The specified peripheral can be reset by writing 1 to the specified bit in the APB-PRSTR0 and APB-PRSTR1 registers. Part 4, RSTCU Application Example. In this part we will learn about the actual reset control operation on HT32 MCUs. Finally, we will summarize the learning content by using an application example. This example is one of the standard peripheral firmware library examples. It should be used with the hardware starter kit and expansion board. Insert the start kit into the expansion board. During the example usage, it is necessary to operate the key 1 and observe the LED 0. Open the example. We can see that the code in the example is mainly divided into 4 sections. The functions of the 4 sections are as follows. Initialize the LED and key control pins. Configure timer to control the LED on and off. Cyclically determine whether the key has been pressed or not. Reset the GPIO peripherals for LED control. The actual effect of the example is that after programming the example into the board and executed normally, we can observe LED 0 on the expansion board is blinking. At the same time, the program will cyclically determine whether the key 1 has been pressed or not. If yes, the GPIO peripheral controlling the LED will be reset. When the GPIO is reset, the LED 0 will change from blinking state to off state. Holtec has a professional service team to assist in the development, design, and after-sales service. Welcome to contact our business unit for more detailed product information and consulting services.